hydrogenation. Because of the double bonds, we can add it in. That's called hydrogenation. Now, hydrogenation, the first time they used is in 90s, early 20th century. They used this is for making soap. And then later on, they first tried the food products is actually around the 1920 to 1930s, they used in modified sorbing, I would say, modified sorbing oil and bakery of shortenings. Now, what's the results of this happens? And this is, we call it alkane. Once you add a hydrogen there, it becomes alkene. Is that right? Or I call it, sorry, opposite way. This is alkene. And this is alkane. Once you add a hydrogen, it becomes alkane, like that. Now, you may think about this. It happens very easy. Not really. How did let this happen? In a closed vessel or closed container, the temperature has to be higher. You have to be heating more than 200 degrees Celsius. And you're going to be repeatedly adding powdered hydrogen atoms or ions. And you need to let this reaction happen real quick. So you need a nickel as a catalyst. Let's happen more quickly and efficiently. But unfortunately, this reaction is always reversible. Especially if this is number one place. If this is number one place, what is going to happen? It's reversible. So when you add it there, it will going to become back. So this guy is gone. Now, very possible like that. Because you think it's already saturated, but the number one position is reversible, then somehow become this configuration, which has become a trans. Because it's a very saturated and stable status. It's not easy to touch it. And when they find this, around 1970 to 1980, when they're making bread, they find it. And now, why this guy is always happens to trans fatty acids happens there? Because this is very stable, so they're resistant to lipids oxidation. We call it rancidity. That's why it started to use in the food industry actually a lot at the beginning for trans fatty acids. But later on, the more research they do, they find it a problem. The liver sometimes do not have the enzyme to hydrolyze it, so it's more stable there. At the end of the day, will cause a clotting of the blood vessel and have a heart disease and high pressure. So that's where it comes from. So, said very easily, what is trans fatty acids comes from? Which is aside reversible products from hydrogenation. Now, some of the commercial products, they do label, say the partial hydrogenation. Okay, because the number one copy is easily to be reversible during that process. They do have a lots of research. They're gonna add some ingredients, try to make sure this don't happen. There are lots of research talk about that. But I tell you at the beginning, it's coming from the side reversible products from the hydrogenation. Okay, so this is cis and trans fatty acids, how they come from. And this is, I just gave you the conclusion. Now, regarding the melting points, of course, cis is lower than trans. Trans fatty acids have a higher melting point. So if we want to do the conclusion, melting points for longer chain, saturated and trans isomers, they have a higher melting points compared to the short chain, unsaturated and cis isomers. So that's a conclusion. Now, this gives you some of the example. Linoleic acids, if you add hydrogens there, it will become oleic acids, which is cis. The same formula, isomer, the trans isomer, which is electric acids. If you keep doing, adding hydrogen, let the hydrogenation finish. Finally, will become stearic acids, which are saturated fatty acids. This is a cis and the trans fatty acids. What they have? The first one, 9,12 cis linoleic acids. Second one, 9,6,12 trans linoleic acids, and the last one is 9,12 trans linoleic acids. What's the mistake here? This double line should be in the opposite direction. What's the difference between these two? If it's like that, no difference. That double line on the top, on the second double line right here, this you have to correct it on the other side. And that's some of the mistake in our textbook. Now they didn't do a good proofreading, so they missed that. If you read, you will find there's a one section which is doubled district again in some places. Okay. So this is what we have for this section, and let's go to the lab. We'll see the what activity, the measurements. So we control the time very well. It's about like 40 minutes, 45 minutes.